Welcome to StatTrek's video tutorial on advanced placement statistics. In this lesson, we cover scales of measurement. You're going to learn what a measurement scale is, and you're going to learn to identify four types of measurement scales: nominal scales, ordinal scales, interval scales, and ratio scales. First, let's talk about what a measurement scale is. In statistics, measurement involves the assignment of a value to a variable. A measurement scale defines the nature of values that are assigned to variables. For example, some scales use words as variable values. Other scales use numbers. All measurement scales can be distinguished by the presence or absence of four properties: identity, magnitude, equal intervals, and absolute zero. Identity says that every value on the measurement scale has a unique meaning. It is not equal to any other value on the scale. Magnitude means that all values on the measurement scale can be rank ordered relative to one another. That is, some values are larger, others are smaller. Equal intervals means that units along the measurement scale are equal to one another. And absolute zero means that the scale has a true 0 point, with no values below 0. In statistics, many analytical techniques work with some measurement scales, but not with others. So to use these techniques correctly, you need to be able to identify the type of scale you're working with. In this tutorial, you will work with four types of measurement scales: nominal scales, ordinal scales, interval scales, and ratio scales. These scales are listed in increasing order of precision. This means that you can do a finer analysis when your variables are measured on interval or ratio scales than when they are measured on nominal or ordinal scales. Nominal scales allow the least precision. The nominal scale of measurement only satisfies the identity property of measurement. Values assigned to variables are verbal labels that have no inherent numeric value. We can't add or subtract values measured on a nominal scale. So the statistical techniques that we can apply to nominal scale variables are limited. Gender is an example of a variable that is measured on a nominal scale. We measure a person's gender by saying they are male or female. This uniquely identifies the person's gender, but it does not indicate magnitude. We would not say, for example, that a male has more gender or less gender than a female. Ordinal scales have the property of both identity and magnitude. Ordinal scales provide information about magnitude because they indicate rank order. An example of an ordinal scale in action would be the results of a horse race, reported as win, place, and show. The horse that won finished ahead of the horse that placed, and the horse that placed finished ahead of the horse that showed. Note that the ordinal scale only reveals rank order. It does not say whether the winning horse barely won or won by a mile. Again, you cannot add or subtract values on an ordinal scale. In a race, 3 show finishes do not equal a win. The interval scale of measurement has properties of identity, magnitude, and equal intervals. Arithmetic operations like addition and subtraction are allowed on an interval scale. A perfect example of an interval scale is the Fahrenheit scale to measure temperature. This scale is made up of equal temperature units, so that the difference between 40 and 50 degrees Fahrenheit is equal to the difference between 30 and 20 degrees Fahrenheit. With an interval scale, you know not only whether different values are bigger or smaller, you also know how much bigger or smaller they are. The ratio scale of measurement satisfies all four of the properties of measurement: identity, magnitude, equal intervals, and an absolute zero. Ratio scales are similar to interval scales in that they allow arithmetic operations like addition and subtraction. The main difference is that the lowest value on a ratio scale is 0. The weight of an object would be an example of a ratio scale. With weight, there is an absolute 0, since objects cannot weigh less than 0 pounds. Let's review. So here is a quick overview of measurement scales. There are 4 types of scales, each of which allows a different level of precision. Precision is determined by the properties satisfied by the measurement scale. Nominal scales allow the least precision. They use verbal labels, not numbers, to categorize objects, and they only satisfy the identity property of measurement. Ordinal scales allow a little more precision. Just like nominal scales, they allow you to categorize objects, and they indicate rank order. But they do not permit arithmetic operations like addition and subtraction. Interval scales do everything that ordinal scales do, plus they define equal intervals, which make it possible to add and subtract values. And finally, ratio scales are just like interval scales, except that the lowest value on a ratio scale is always 0. To use analytical techniques correctly in statistics, you need to understand which measurement scales were used to assign values to variables that you work with.
That's all, folks.